Imagine a universal remote that controls your TV, sound system, and air conditioner. Each device responds differently to the power button, but the remote just sends a signal. This is similar to polymorphism in programming. In this video, you'll dive into another essential concept in object-oriented programming called polymorphism. By the end, you'll be able to identify what polymorphism is, understand its benefits, and be aware of its complexity. Polymorphism is a term derived from Greek, where poly means many and morph means forms. Thus, polymorphism essentially means many forms. Consider a musician who can play multiple instruments, such as guitar, piano, and drums. When asked to perform, you don't need to specify which instrument to play. In programming, polymorphism allows a single method to work differently depending on the object it acts upon. This means you can write code that works on the superclass type and automatically with any subclass type. Recall the repair method in the garage class explained earlier. This method takes a vehicle type of object as an argument. Because the car is a subclass of the vehicle, you could easily pass a car object as an argument to it. The repair method demonstrates polymorphism because it works on the superclass type vehicle, but automatically works with the subclass type car. Polymorphism in Java is implemented using method overloading and method overriding. Method overloading is like a Swiss Army knife. It has multiple tools, such as a knife, a screwdriver, and a bottle opener. Each tool serves a different purpose, but all are part of the same Swiss Army knife. In programming, method overloading allows a class to have multiple methods with the same name but different arguments, just like the Swiss Army knife has various tools for several tasks. Here you have a class called shape with two methods named draw. The first one takes no arguments and prints drawing a shape. The second takes a string argument and prints drawing a shape with color, followed by the color. The method name is the same, but the arguments are different. Hence, it demonstrates method overloading. The main method creates an object of the shape class, referenced as random shape, and calls both variations of the draw method. The second call to draw passes red as an argument. The output confirms that both methods are working as expected. The one with no arguments prints drawing a shape. The overloaded method that takes the shape's color as an argument prints drawing a shape with the color red. Method overriding is like hiring a new chef in a restaurant. The restaurant has a standard recipe for a dish, but the new chef decides to add a twist to it. The dish is still known by the same name, but has a different flavor. In programming, method overriding allows a subclass to provide a specific implementation of a method already defined in the superclass, just like the new chef's unique twist on the standard recipe. Returning to code, consider a class named circle that inherits from shape and rewrites the draw method without arguments to print drawing a circle. Observe the annotation at the rate override. It indicates that the following method exists in the superclass and is being modified in the subclass. Getting back to the main method, the shape reference bangle refers to the object of the circle class and calls the draw method without arguments. Yes, the superclass reference can refer to the object of its subclass. Observe the output. It says drawing a circle because the draw method with no arguments is overridden in the circle class to print. Remember that when you override a method in the subclass and call it using a reference to the subclass's object, as bangle here refers to the circle object, the overridden version of the method will always get called. Now that you've explored polymorphism and how it works, let's explore why it's such a powerful concept in programming. Understanding its benefits can help you write more flexible, reusable, and maintainable code, making your development process smoother and more efficient. Polymorphism enhances code reusability by allowing the same method names for different tasks, similar to a universal remote controlling multiple devices. It adds flexibility, enabling easy handling of new cases, without needing new code, such as setting up a new device to work with the same remote. It also improves maintainability, as changes in the superclass reflect in all subclasses, like updating universal remote software benefiting all controlled devices. However, polymorphism complicates your code, requiring careful design and understanding of class relationships. Improper use can lead to code that is hard to understand and maintain. It's like a sophisticated universal remote with many buttons. If you don't use it carefully, you might press the wrong button and get unintended results. In programming, this means ensuring class relationships are well defined and methods are used correctly. To summarize, polymorphism enables objects to be treated as instances of their superclass, providing many forms of the same method. It includes method overloading, where methods have the same name but different arguments, and method overriding, where a subclass can redefine a method already defined in its superclass. While polymorphism offers significant benefits regarding reusability, flexibility, and maintainability, it also introduces complexity that requires careful design. It's like using a universal remote control, extremely powerful and convenient, but only if you know how to use it properly.